Morning, all. Let's start with the basics of number system today. In computer science, whenever we talk about basics of computers, the concept of number system is something which is very important for all of us. What is basically number system is? So we all know that numbers are made of different symbols. The symbols are 0, 1, 2, something like this, or it may be A, B, C, D. So, depending upon the number of these symbols, there are different type of number system. When we talk about a decimal number system, what does it means? The deci over here comes from the word 10. So it means that there are total 10 symbols 10 symbols which will be there in a decimal number system. So, what are those 10 symbols which are represented in a decimal number system? They are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Remember, starting with 0 till 9, these are total 10 symbols. These 10 symbols make decimal number system. So any number which can be represented with these 10 symbols, it comes under decimal number system. So when we write this as a symbol, how does this number system come into the picture and how a number is made? Let us see this with an example. For example, let us consider a number 109. So in this 109 we have got symbols 9, 0, and 1. It is made of three symbols 9, 0, and 1. And when we check its position from right hand side, number 9 or symbol 9 is at position 0 from right hand side, symbol 0 is at position 1, and symbol 1 is at position 2. So position from right hand side is 0, 1, and 2 for this symbol 9, 0, and 1. Now this gives it a positional value. Positional value is calculated by 10 to the power of the position from right hand side. So 10 to the power of 0, 10 to the power of 1, and 10 to the power of 2. So when we divide this 109 in three simple symbols, that is 9, 0, and 1, and we calculate its positional value, it comes to be 10 to the power 0, 10 to the power 1, and 10 to the power 2. The decimal equivalent of this is calculated by symbol, symbol that is 9 in this case, symbol multiplied by positional value, and positional value is 10 to the power 0, that is 1, so it comes out to be 9. Similarly over here 0, the symbol multiplied by positional value 10 to the power 1, which is 10, and 0 multiplies it gives 0. Then symbol that is 1 multiplied by positional value, which comes out to be 100. And then on adding these these three things gives the final value, that is 109. So this is how a number is being made in a decimal number system. So the main concept is the position from right hand side, that is the position from right hand side. Then second main concept is the positional value, that is 10 raised to the power of position from right hand side. And then the third concept is the decimal equivalent of the number. So the decimal equivalent is calculated by symbol multiplied by positional value. So symbol multiplied by positional value, and then adding all these three things gives us the decimal equivalent of the number. So this is what is the basics of number system, which tells us about that how a number is being made. Now there is other number system which is very important in computer science, and it is known as binary number system. A binary number system is important because computer understands only one language all of us know, and that is a binary language. So binary number system is very important. Binary, as the name suggests, by means two, so there can be only two symbols. Now those two symbols which makes binary system is 0 and 1. So binary number system is a number system where all the numbers are represented by only two digits, two symbols, that is 0 and 1. Now for the numerical part, a very good question which comes in examination is that we convert a decimal number system which is represented to the base 10 to an equivalent binary number system. Now, how does this conversion takes place for a decimal number system to a binary number system? So let's study the conversion of a decimal number system to a binary number system. Let's take a small digit for our example, and let's take 18. So 18 is a decimal number system having two digits 1 and 8 represented from 0 to 9. We have to find a binary equivalent of it. So the simple process of converting a decimal number system into a binary number system means base 2. So we have to convert these 10 digits into 8 2 digits, 10 digits into 2 digits. So smaller conversion is required. So we do division. So we divide the number which has to be converted by 2 because we have to convert into base 2. And on division, 2 nines are 18 and remainder is 0. We write down the remainder over here. These are the remainders. We write down the remainder over here. Then again we do the conversion. 2 fours are 8 and remainder is 1. Then we convert by divide again by 2. 2 twos are 4 and remainder is 0. Then again 2 ones are 2 and remainder is 0. Then 1 can also be divided. That 2 we know that two zeros are 0 and remainder becomes 1 and remainder becomes 1. So two zeros are 0 and remainder becomes 1. So we get all these remainders. Now the answer of the question is all these remainders, written from bottom to up. All these remainders written from bottom to up is the answer. So how do we write it? From bottom to up, 1 0 0 1 0. So this is an equivalent number system in binary number system. So 18 is represented with the number system in binary by the symbols 1 0 0 1 0. This is the answer for conversion of decimal number system to binary number system. Remember that we find the remainders, and even the last remainder is divided with 0 and it comes as a remainder, and we write all the remainders in the reverse order, that is from bottom to top. So this is how a conversion is done from a decimal number system to binary number system. Now in the next video we will see a very important topic, that is conversion of a fractional decimal number to a binary number.